Ladies and gentlemen, boys and girls, welcome to another edition of Mastery Algebra 1. I'm Mr. White. This is Lesson 6-5A. Who's in the shade? Back in recent activities, we graphed inequalities with one variable on number lines. That was one dimension. Now what we're going to do is we're going to look at inequalities involving two variables, usually an x and a y, okay, that give us coordinate axes or two dimensions. So if we start investigation with looking at this inequality, y is less than or equal to 1/2 x minus 2. Because we don't know x or y, we have to figure out a bunch of solutions that are going to give a true solution. Meaning, when we plug in a number for y and x, we should get a true statement. Okay? So number one, we want to ask, which of the following points satisfy the given equality? Okay, show how we know. What we're going to do is we're going to input our x and our y into the following inequality. So we know our 2 is the y, which is less than or equal to 1/2 times the negative 3 minus 2. Simplifying, we're going to get 2 less than or equal to negative 3 divided by 2 is negative 1.5 minus 2. When we put that together, we're going to get 2, which is less than or equal to negative 3.5. So here's our answer, and we have to ask ourselves, is that a true statement? And the answer is no. So this is not true. What really is true is 2 is greater than. So let's just move down. Let's go to C. If we plug in C, we're going to get negative 1 is the y, which is again less than or equal to 1/2 times 0 minus 2. This is going to give us negative 1 less than or equal to negative 2, okay, which is again a false statement. Negative 1 again is greater than 2. If we move down again, we look at E. We're going to plug in negative 5, which is again less than or equal to 1/2 times the negative 6, and then go minus 2. We're going to get negative 5, which is less than or equal to negative 3 minus 2, and negative 5, which is less than or equal to negative 5. So we want to ask ourselves, well, it's not less than, but it is equal to. So this is a good statement. So E works. If we do one more down here, if we plug in 6, negative 2 to the same inequality, we're going to get negative 2, which is less than or equal to 1/2 times 6 minus 2. Negative 2 less than or equal to 3 minus 2. We end up getting negative 2, which is less than or equal to 1. Okay? That is a true statement. So we can circle this one, okay, because it is less than. All right, based on A, C, E, and G, go ahead, hit pause. Do the same thing for B, D, F, and H. I'll see you back here in a few minutes. Go. Welcome back. As you can see with B, D, F, and H, B, F, and H all gave us true statements. D did not. We end up getting negative 1, which is less than or equal to negative 3, which is not a true statement. So this is going to carry over later in the lesson when we plug in certain points and see if we get a true statement or a false statement. 2a, we want to draw the graph of y equals 1/2 x minus 2. So notice, if you remember from section 6.1, we have their y-intercept at negative 2. So we're going to go down to negative 2. And then from the negative 2 point, we're going to use our slope of a rise of 1 and a run of 2. So we're going to go up 1 and over 2 and put a point. Up 1, over 2 and put a point. Up 1, over 2 and put a point. We could go down 1 and left 2 and get our other points. So we get this nice graph line here. Okay? So that's our graph of y equals 1/2 x minus 2. B, which points A through H above make y equals 1/2 x minus 2? Which ones are true? Which ones give us equal to? So we're looking at our E gave us an equal to. F gave us an equal to. So E, F, and then we have H also gave us an equal to. So if you mark these points, E is negative 6, 5, which was way over here. There's E. F, which was 4, 0. There's F. And H, which was 6, 1, which is a little further out there here. So we have H. So those are our 3 points there. So if we look at letter C, 2C, where do these points lie compared to the graph of y equals 1/2 x minus 2? They are, if you notice where we put them, they're on the line. Now, D, we need to identify 3 more points that make y equals 1/2 x minus 2 true. And then we're going to plot these on. We can label them as I, J, and K. Well, if we look, in order to be equal, or solutions that are equal to on a line, we're going to look that's on a line. So we can actually go start from E. We have a point that's right here that's on the line if we went up 1 and right 2. So we'll call that I. If we go up 1 and right 2 again, we'll call this J. You can go up again and we can call that K, or we could call this K. So any one of those left 4 points is considered to be on the line. If we look at 3A, which of those points, A through H above, make y less than 1/2 x minus 2? So we scroll back up. We want less than. So by putting the little symbols on the left-hand side, if we notice A was greater than, C was greater than, G was a less than. Okay. We have B was a less than, and that's it. So we're going to mark down G and B. Okay. Where do they lie on the graph? Okay. G and B. G. G is 6, negative 2. So we're going to go 6, negative 2. Here's G. B is 2, negative 3, which is here. So if we ask our question for 3B, where do these points lie compared to that graph y equals? They are below the line. If we go to C, we need to identify 3 more points that make y less than 1/2 x minus 2, or y is less than that. We're going to plot these on the graph. We need to label them L, M, and N. So another one we can put, let's just put here on the far left, let's call that L, okay, which is negative 6, negative 6, could be our L. We could do M, let's just put a point right here, that's M, at 1, 2, 1, 2, 3, 4, 5. So this is negative 2, negative 5. And if we do one more, way over here in this corner, let's call this N at where it was 6 and negative 6. So positive 6, negative 6. So all 3 of those are below the line. D says if we colored in every point that makes it y is less than the 1/2 x, what would the graph look like? So if we color all those points that are below the line, we're going to get this graph like this. So D, if we colored in every point that makes y is less than 1/2 x minus 2, what would it look like? Everything under the line would be shaded. All right, next page. Which graph to the right shows all of the solutions to the inequality y is less than or equal to 1/2 x minus 2? So we're looking for all the y's that are less than or equal to 1/2 x minus 2. If we compare it to the graph that we just got done, when we said less than, we were looking at answers that were below the line. So the shaded region that's below the line looks like graph number 2. 5. We need to match the inequality with this graph to the right. So the first one, we have y is greater than or equal to 1/2 x minus 2. So if we look at the 4 graphs, 1, 2, 3, and 4, first thing we need to know is on 5a, we have a y-intercept of negative 2. So we're going to look at which line gives us a y-intercept of negative 2. Okay, and that would be graph 1. We have graph 2, and that's it. So it's either going to be graph 1 or graph 2. Okay, based on the answer for graph 1 and graph 2, okay, this time on 5a, we want all the values that are greater than or above the line. So that matches with graph 1. 5b, y is less than or equal to 2/3 x plus 2. So now our y-intercept is going to be at plus 2. But if we look at c, the difference between b and c is we want values below the line versus on 5c, we want y values that are above the line. So if we look at our graphs, this has to be either graph 3 or 4, and we want answers that are below the line, so that's going to be graph 4. Therefore, 5c is graph 3. 6. How is the graph of an inequality different from the graph of an equation? Okay. Well, equation, really what we've been doing is it's just a line. Okay. With an inequality, if you notice what we've just added, is now we're adding shading. Okay. We are looking for, if you remember back on chapter 3, we are looking for more values that are solutions. So in our shading, we are looking for all the points that are solutions. 7. On the same grid as graph 1, draw the graph of the inequality y is less than or equal to negative 2x plus 3. So we scroll back up here. We're going to start at plus 3. So we'll use my blue marker. If we go up 1, 2, 3, we're going to put a point. Now we're going to have a slope of negative 2. So we're going to go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. We get this graph. It's a line here and goes up and continues here. Now to continue, remember we have the inequality, and it said we want on 7, we need to shade the regions that are less than or below the line. So we're going to shade all of this region that is below the line. So we get that graph. 8. On the same grid as graph 2, we're going to draw y is less than or equal to negative 3/2 x plus 2. So this time we're going to start with a positive 2. So up 2 on the y, we're going to go down 3 over 2. Number 8, on the same grid as graph 2, we're going to draw the graph of the inequality, all the y's that are less than or equal to 3 negative over 2x plus 2. So if we start at 2 on the y-axis, then we're going to go down 3, 1, 2, 3, and right 2. We can put a point. If we go down 3 more and over 2, we can put another point. Let's go back to our original 0, 2 and go up 1, 2, 3, but left 2. We can get a line that connects through these points here. And then again, shading wise, we're looking for, because it's an inequality with shading, we're looking for all the y values that are less than the negative 3/2 x plus 2. One other thing, if you're not sure above or below, let's take a point 0, 0. If you notice, 0, 0 is below the line right now. So if you plug in 0 for y and 0 for x, by simplifying, you're going to get 0 is less than or equal to 2. Is that a true statement? And the answer is yes. Since we get a true statement, we are going to shade that point 0, 0. So we're going to shade this way or below the line. Number 9. On graph 3, we're going to draw the graph that's all the y's that are greater than or equal to negative 1/2 x minus 4. So we're going to start with 0, negative 4 for the y-intercept. And then from that point, we're going to go down 1 and right 2 and put a point. Down 1 and right 2 and put a point. Let's go back to the original negative 4 and go up but left. Up but left. And we have some more points. If we connect the dots, we get this line here. Now we're interested in all the values that are greater than. So if they're greater than, we're going to shade above the line. If we draw our lines, and we get that graph. And number 10, we need to draw the graph of the inequality y is less than or equal to negative 1/3 x minus 1. So if we start at 0, negative 1 on the y-axis, and we're going to go down 1, right 3, down 1, right 3, go back to the original negative 1, up 1, left, up 1, left. We will get this graph here, and we are shading all the values that are now less than or below the line. Okay. Just like I did just above though, if I plug in, notice 0, 0 is above the line. So if I plug in 0, 0, we're going to get, by simplifying, 0 is less than or equal to negative 1. Is that a true statement? The answer is no. So we do not shade the side of the 0, 0, which is above. We shade below. Okay, number 11, how would the graph of y is less than or equal to negative 1/3 x minus 1 have to change in order to graph the y is less than negative 1/3 x minus 1? In other words, how would you not include the points where they are equal to? Okay. Well, if you think again back to lesson or chapter 3, okay, when we had versus equal to and not equal to, we used dotted lines. So this line right here, this would become a dotted line instead of a solid line. Hey, congratulations. This concludes sections 6.5a. Continue on to 6.5b. Remember, do your best, forget the rest. Bye for now.